Fill the brain with high thoughts, highest ideas. Fill the brain with high thoughts, highest ideas. Place them day and night before you. Place them day and night before you. And out of that will come great work. Out of that will come great work by Swami Vivekananda. Hi everyone, this is Akshay, Faculty of Mathematics, Vivek Vidya Youth Forum, New Delhi. In this particular lecture session, we will be dealing with example numericals based on the topic of nature of roots. In the previous session, we have went across the introduction to nature of roots and on what basis the roots can be found out. Right. Let's get started. Just a minute. Find the discriminant of the quadratic equation. So this is the equation which is given, and find the nature of the root. So compare the given equation with the standard form of quadratic equation. On comparing it, write A, B, and C separately. Discriminant D is given by the formula B square minus 4AC. So if B square minus 4AC is less than 0, then they have no real roots, or we can say roots are imaginary. Roots are imaginary. Okay, so the roots are imaginary. You can conclude it like this. So this is how any other equation which is given, you will be finding the discriminant by this method, discriminant, and then you will say the nature of the root based on the value of the discriminant you have got. Right. Next question. Okay. A pole has been erected at a point on the boundary of the circular part of diameter 13 meters square in such a way that the difference in its distance from two diametrically opposite fixed gates A and B on the boundary is 7 meters. It is possible to do so if, yes, at the distance from the gate A and B, what should be the what distance will be between A and B, at what distance the pole is erected. So we have to basically draw the diagram for this. So diagram is the only one which is going to tell us how is it. So this AB wouldn't look like diameter, but it is diameter. AB is a diameter. AB is a diameter. And PB is the erected part. PB is the erected part. Okay. So now let P be the required location of the pole. If you have to imagine few things because we cannot show it over here. It's all based on your imagination. You see a circular plate, okay, and it's standing upwards. And the direction of and the distance of the pole from the gate B will be X. This distance will be taken as X meters. Since here it is 13 meters, it will be X meters. And now the distance of the pole from the two gates AP minus BP or BP minus AP. Either of them, the difference between the two distances is 7 meters. Either of them. So we consider AP minus BP itself. So AP will be x plus 7 meters. Either of them can also be chosen. X plus 7 meters, you will get AP. So I will write down that in the diagram. This AP is x plus 7 meters. X plus 7 meters. Since AB is 13 meters, and since AB is the diameter, AB is the diameter and AB is 13 meter, angle APB is equal to 90 degree. So here, how did you get to know angle APB is 90 degree? So angle in a semicircle is 90 degree. Angle in the semicircle is 90 degree, or angle made with the diameter with a point at the circumference is 90 degree. Is a right angle basically. So this from geometry, write it next to it, from geometry, from geometry. And therefore we know Pythagoras theorem, application of Pythagoras theorem over here. Okay, apply the Pythagoras theorem. You will get this as the equation. Required equation. And this equation can be further simplified. Yeah, what happened over here? Yeah, the same equation has been further simplified over here. This is the simplified version of the equation. X is the distance of the pole from the gate P, and that satisfies this equation. So upon solving this, to see whether we are getting roots or what, we will be finding out the discriminant. Discriminant here is greater than 0. So we get roots are real and unequal. Roots are real and unequal. Right? Upon solving this equation, I suggest this equation can also be solved by the method of splitting the middle term. So I have space over here. So let me try that splitting the middle term method over here. So x square plus 12x minus 7x minus 60 equals 0. X minus 7. Sorry, not 7x minus 5x. So wait, I will clear this. 1 minute. I will write it from the beginning over here. X square minus, sorry, plus 12x minus 5x minus 60 equals 0. Splitting the middle term is over. Now you are grouping it. X plus 12 minus 5, x plus 12 equals 0. X plus 12 into x minus 5 equals 0. So x is either equal to minus 12 or x is equal to plus 5. So yeah, by quadratic formula method also you are getting these two as the answer. So here, since it is a distance, x is a distance, x cannot be negative. So minus 12 is ignored. X is only plus 5. So the distance is plus 5 from the gate B and 12 meters from gate A. From the gate A. 12 meters from the gate A. Okay. Hope this is understood and this is clear. Next question. Find the discriminant of the equation. Equation 3x square 3x square minus 12x plus 1 by 3 equals 0, and hence find the nature of the root, and then if they are real and real or equal. If they are real, just find if they are real. Okay, so in order to simplify further, either get it to the standard form or fractional also you can take it. Just compare it with the standard form of the equation. Let me just write it. Ax square plus bx plus c equals 0. Compare it with this. Compare it with the standard form ax square plus bx plus c equals to 0. And therefore write the discriminant b square minus 4ac. Find it. It is equal to 0. So what can we conclude? The roots are real and they are equal. Two roots are equal and they are real. So minus b by 2a minus b by 2a. So this is how we actually get. So I will say how you get it as minus b by 2a. We know x is equal to minus b plus or minus root of b square minus 4ac divided by 2a, right? So we know this b square minus 4ac will get into 0. So x will be equal to minus b by 2a plus or minus 0. If it is plus 0 also, it will be minus b by 2a. If it is minus 0 also, it will be minus b by 2a. So both the roots are real and they are equal. Upon simplifying, you get it as 1 by 3. So this is the required solution. This is the required solution. So before saying thank you, let me just project it from the beginning. Take down the notes. Though example numericals would have been given in the textbook, I would have solved it again back so that it will be easy for me to explain, and I can write about few things on the either side. So yeah, let me just revise whatever we have taught in this session. So we went across nature of fruits, finding the nature of fruits, finding the discriminant, and then getting the nature of fruits, and then solving the quadratic equation using any of the three methods. Right. And thank you. Let's meet up with the next session with exercise numericals of the topic nature of fruits of this chapter. Thank you. If you have liked this video, please click on the thumbs up button, share this video, post your doubts in the comment window so that we can get back to you.